Number 2, the graph of part of a linear function g is shown on the grid. Which inequality best represents the domain of the part shown? So domain goes with our x value. X is going sideways, horizontally, left and right. So that's what we're going to look for. We're going to look for how far to the left and how far to the right does the graph go. This graph is continuous, so that means we need to include all the decimals in here also. So that's why we're using this form with our inequalities. So when we look farthest to the left, how far to the left we go here. How far to the right does it go? Right here. And again, we find those numbers on our x-axis because the x goes with domain. So we have a -3 right here and right here on the left side. And then to the right, we have our 2, and we have a 2 here and here. So we can eliminate choice F. These don't have the right numbers, and choice J. Those don't have the right numbers. You'll also notice this is an open circle. So you can remember from class how I have my ghost set up. If the ghosties have their little bags under their eyes, that was the one that was colored in. If they're not, it's just open circle. So this is our less than symbol is going to make this open circle. And these will be closed because of the or equal to. So these are both the same symbols. So now we have to look in the middle, g of x. And remember, we're not going to get freaked out when it says g of x, because g of x is another way to represent that y value. So it's looking between y and x in the middle. And we want domain. Domain goes with x. So the correct answer is going to be H. Question number 3. The total cost in dollars to buy helmets for the players on a football team can be found using the function C equals 100H plus 8.25, where H is the number of helmets bought. If there are at least 49 players, but no more than 53 players on the football team, what is the domain of the function for this situation? We're looking for domain again. Domain goes with x. X goes this way. And for this question, we actually don't have an x, so we need to look at these variables to figure out which one represents our x. And it's going to look like this. We have our y equals, and then our x would be here. And so right now it says h, so that means our h means the same thing as our x. And h is the number of helmets bought. So helmets is going to be our independent, our domain. So we have to look for the number of helmets, and it says right here. So if we have 49 players, but not more than 53 players, each of those players needs a helmet. So the lowest number is going to be your 49, and then your highest number is going to be your 53, and it needs to be everything in between. Okay, now here's a 53 also, but our low number is 49, not 0. And it can't be this one anyway, because this would include decimals. And when we're talking about players, each player needs a helmet. We don't order parts of a helmet. We would order 49 helmets, or 50 helmets, or 51 helmets, 52, 53. We don't order the part of the helmet for the players. So your final answer for this one is going to be A. Question number 4. A man walked from his house to his workplace. The graph shows the man's distance in miles from his workplace after walking for X hours. So whenever they tell us a variable, it's a good idea to make that stand out so that you can remember what it stands for. This question is talking about range. Range is going to be our y variable. And our y variable goes up and down. Okay? And we're going to start our low to our high whenever we're looking on our graph. So the very lowest that we're going to go is all the way down here we're on our y-axis, so I'm going to circle my number here. the highest that we're going to go is right here. And so we're going to circle our number again on our y-axis because range is your y-axis. So we're looking at numbers 0 and 5, and it's going to be everything in between here. So we don't have inequalities this time. We have to use our words, but we can still go look for these numbers. So we have a 0 and a 15. We have a 0 and a 5. And we have a 5 and we have a 15. So for this one, we're going to need G. And let's read through the rest of this question. All real numbers, that includes decimals. Okay, and that's what our continuous line is representing. Greater than or equal to 0, so it's got to be bigger than 0, or it can be equal to, and it's a solid dot. Less than or equal to 5. So if we go up to 5, that means the graph has to go less than here, so it's going to go down these numbers, and it could also be equal to because there is a closed circle. So G is correct. Question number 5. Which table represents y as a function of x? This question is a very fancy way to say which table is a function. So we're going to go look at the x column because that's where we see if something is a function. What we're looking for is that all the x's are different. So we're going to go look down our x column only. We don't even care about the y column for function. And I see that we have -1s here, so this one is not a function. We have a whole lot of repeating, so this one is not a function. Here again we have some zeros that repeat, and we also have ones that repeat, so this one is also not a function. And then we also have here, oh, these are all different, so this one's our function. Whenever you're not sure what the question is asking, you can do what I just did and go through all of your answer choices, and you can play which one of these things is not like the other. So we have one answer for this question. Which table represents the function? Right here, answer choice D.